I'm pretty good. How are you?
Good.
Good.
All right, you got stuff that you can verbalize tonight?
Yes. All right. All right. It says, okay, it's a imaginary number problem,
Okay.
and it's in parentheses 5 minus 3i squared.
Like that?
Yep, that's it. And then it just says to perform the.
Okay. How are we going to do this?
So I thought you did. Hold on, the 5 times 5.
Well, it's the same. 5 minus 3i squared is the same as this.
Yeah.
And you just FOIL it. In other words, you want to FOIL it in the same way you would FOIL x minus y times x minus y. So what's the first term?
25.
Next term?
15i.
Plus or minus?
Minus 15i.
Next term?
Minus 9i squared.
Hold on, there's another minus 15i there.
Oh, yeah.
In other words, when we FOIL it, we multiply that times that, and then we add to that multiplied by that, and then we multiply the inside, and then we multiply the outside. In other words, it's every term by every term. And the last term is plus 9i squared. Okay? Now simplify that answer.
25 minus 30i plus 9i squared.
What's I squared equal to?
Negative 1.
Okay, so simplify further.
Minus 9.
Okay,
So 16 minus 30i.
there you go. That's your answer. So there's nothing special about imaginary numbers other than the fact that I squared is equal to minus 1. And you're constantly, whenever you're doing arithmetic with imaginary numbers, you're constantly looking at an I squared that you have to replace with minus 1. In other words, you can turn an imaginary number into a real number by having it be squared. I squared is a real number, whereas I is an imaginary number. Like imaginary playmates. I've always thought the name is kind of funny, imaginary numbers.
Yeah, it's kind of weird.
Well, it makes it seem like they don't really exist. And they don't. Imaginary numbers are a tool that mathematicians use in order to do higher math.
Alright, my next one is negative 7 minus 2i over negative 9 plus 4i.
Okay. This looks like a division problem, but it isn't.
Oh.
In the same way that if I said, what is 1 divided by square root of 2? That is not a division problem. How do I simplify that? 1 divided by square root of 2.
Square root of.
Well, the job here is to rationalize the denominator, right? It's not really to divide square root of 2 into 1. It's to turn the denominator into a real number. So if I multiply this thing by square root of 2 over square root of 2, which is the number 1, I can multiply any fraction by the number 1 without changing its value. So that thing turns into that. And I didn't really divide, I rationalized the denominator. Same thing with imaginary numbers. we're not really going to divide that into that. We're going to multiply by the conjugate. What's the conjugate of the bottom? Just change the sign in the middle.
So -9 minus 4i.
Right? Since I multiply the bottom by that, I got to multiply the top by it. And the reason we multiply by the conjugate is that's going to get rid of the I. It's going to turn it into a real number. So let's do this foiling here, or multiply every term by every term. What's the bottom turn into? Do it piece by piece.
So 81.
Okay.
Minus 36.
Plus 36i. In other words,
Plus
minus 9 times minus 4i is plus 36i.
Then minus 30, or then, yeah.
Yes, minus 36i. These two terms will always cancel themselves out when you multiply by the conjugate. So you really only need the first term and the last term. What's the last term?
Plus 16i.
Okay, it's plus 4i times minus 4i. What is it?
Minus 16i squared. Okay. So
notice that cancels with that. The I squared I can replace with a minus 1, so the denominator turns into a real number. What is it?
97.
Good. And now the numerator. So we still have to multiply that times that, and the imaginary part will not disappear here. We'll be left with an I in the numerator, but that's okay. You can have imaginary numbers in your numerator, you just can't have them in your denominator. So what's the new numerator? It's minus 7 times minus 9. Jade, did I lose the audio? Okay. Yeah, on my GoToMeeting it says Jade is offline now. So it somehow has lost your connection. The easiest, nothing happened to your computer, it didn't freeze up or anything? Okay. Why don't you log out of GoToMeeting. In other words, hit that X in the upper right. And I'll see it when you do that. It should disappear from my end. Are you out of it? Okay, now log back in. And I'll give you the meeting ID number again. It doesn't show you as logging out on my end, which means it doesn't recognize you as being there. It's okay, it should work still. Right. I would guess that you're going to have to reboot your computer. In other words, it does sound like you're kind of hung. if you can't run GoToMeeting, it's either because it thinks you already have it running, it didn't log you out. What's it doing when you double click on the GoToMeeting icon? Just spins? I would say reboot your computer and start everything again. And you still have the meeting ID number from my text message? Okay. I'll just sit here and hang out. It'll probably take you 5 minutes to reboot. It's a long process anymore. But I'll speak to you shortly whenever you get back in there. And if you have troubles with it, why don't you call me back and maybe I can figure out something else. Okay. All right. Bye-bye. Did we finish this problem or not?
No.
Okay. We needed to, hold on here. We needed to figure out the numerator. In other words, all we did was the denominator. We need to multiply minus 7 minus 2i times minus 9 minus 4i. So what does that become? Term by term.
Hold on. I need to go grab a computer charger.
Still there? Hello? Okay. Did it go off again? Oh, it ran out. It ran out of battery. Okay. It looks like you may. Okay. You just went from offline back to regular. Are you back on? Say something out loud and I can see whether I can hear you or not. I don't have any audio on my end. Can you see my screen? It looks normal to you? Can you hear me? Testing, testing? Okay. So you don't have audio either. Do you have a home phone that I can call and you can sit there and hear it on a speaker? Is there a home phone with a speaker nearby or your computer? And we can do the audio that way. I need to call back. Yeah, I can't do it with my phone up to my ear like this, but I can call you on Google Phone. And yeah, what's your cell phone again? Here, let's make sure that that's going to answer. Is it ringing? Okay, I'll talk to you shortly.
All right.
Okay. So we should be able to finish the session this way. And in fact, if we ever have audio problems, this is always a satisfactory solution, at least from my end.
Yeah.
I don't know how hard it is for you to do it like this, but all right. So we're back to, we need to multiply these numerators. So multiply the two imaginary numerators together.
It's like cutting in and out. I can't really hear you.
Can you multiply the numerators together?
Yeah.
Okay. Give me the terms.
What is that? 63.
Okay.
Plus 28i.
Okay.
Plus 18i.
Okay.
Plus 8i squared.
Okay. Now simplify that.
63 plus, what is that? 38.
46i.
46i. Minus 8.
Simplify that.
55 plus 46i.
Okay. So there's our answer. Now, it may be that your teacher wants it in standard form, which is a plus bi. I don't know. Would she accept this answer, or would she want it in a plus bi format?
Well, it's like in
It's close to a plus bi format. The only thing I need to do to put it into a plus bi format is to break this up into two fractions. In other words, it's 55 over 97 plus 46 over 97i. In other words, that would be a plus bi format. Okay? Where you have two separate numbers. This is the real part, this is the imaginary part, and that's the coefficient, the real coefficient of the imaginary part. Okay, what else you got?
I have like this equation, and it's x over x squared minus 4, and I have to find the x-intercept, the y, the vertical, horizontal, slant, asymptote, hold the domain, and graph it.
Okay. Let's talk, first of all, let's factor the bottom. What does x squared minus 4 factor into?
X plus 2, x minus 2.
Okay. Now let's figure out the vertical asymptotes. Those are the easiest things to figure out. Where do you get vertical asymptotes? They're always vertical, imaginary vertical lines, not imaginary.
That's the domain, right?
Well, it's where you're dividing by 0. That's the one thing you cannot do in math, is divide by 0. So whenever this denominator is equal to 0, we're going to have a vertical asymptote, which our function, our graph, cannot cross. So I got two of them. Where are they?
Minus 2 and plus 2.
Yeah, they're actually equations of a line. The equation of that line is x equal minus 2, and the equation of this line is x equal plus 2. So the vertical asymptotes are that. They're equations of a line. They're not a point. So there's the vertical asymptotes.
So it's x plus 2, x minus 2?
No, the vertical asymptotes are x equals minus 2 and x equals plus 2. This line right here, the dotted line, is x equal minus 2. This dotted line is x equal 2. That's the two values of x that would cause division by 0. So whatever our graph looks like, it's not going to ever cross these two dotted lines. Okay? What's the horizontal asymptote?
That's
There's 3 different scenarios for calculating horizontal asymptote. One is when the degree in the denominator is larger than the degree in the numerator, the highest degree. The highest degree in the denominator is x squared. The highest degree in the numerator is x. When that happens, you have a horizontal asymptote of y equals 0, which is the equation of a horizontal line. There's two other cases, and that would be where the degree of the variable in the numerator is the same as the denominator. In other words, if I had something like that. If that is the case, then the horizontal asymptote is the ratio of those coefficients. So if I did actually have an x squared up there, ratio of the coefficients is 1, horizontal asymptote would be y equal 1. Okay?
Okay.
If it was 3x squared over 2x squared, the horizontal asymptote is y equal 3/2. You with me?
Yep.
Okay. And the only other scenario is where the degree in the numerator is higher than the degree in the denominator. In other words, we'll make that x cubed. And what you do here is you actually do the long division. You go ahead and divide that into that and deal with the answer. And this results in an oblique asymptote. Have you studied those?
No.
Okay, well, let's not go there then. We'll leave it at numerators that have equal or smaller degrees than the denominator. This case, x has a smaller degree than x squared, therefore my horizontal asymptote is y equals 0.
Okay.
Okay, so I got vertical asymptotes, I got horizontal asymptotes. Where is the y-intercept? And how do I calculate it?
You make all the x 0.
Okay, so the y-intercept must be 0. If that numerator is 0, it's 0. So we're going to have the graph go through that point. We know for sure that the graph will go through that point. What else did they want to know about this function? Besides vertical, horizontal asymptotes, x-intercept. Oh, they want x-intercepts.
Yeah.
The x-intercept is where y is equal to 0.
Yeah, I'm not quite sure how to do that.
Well, if I make y equal to 0 and try to solve the equation, y is only going to ever be 0 if my numerator is 0. So when x is equal to 0, y is equal to 0. So not only is that an x-intercept, but it's also a y-intercept, that point. Okay, notice that it's both an x and a y-intercept. Okay, and that's the only x and y-intercepts. So we've got both of those. What does it want besides that?
Domain.
Okay.
And I got it too.
Well, the domain is x. What can x not be?
2.
It also can't be minus 2.
Okay.
So the domain is generally more about what x can't be than what it can be. Usually x can be anything. But in this particular case, there are two numbers that x can never be. Because if it's ever 2 or minus 2, it's going to cause division by 0. So the domain, do you have to give it an interval format, or can you just say all reals except 2 or minus 2?
I can just say all real.
Okay, so the domain is x is a member of all reals except x can't be equal to 2 and x cannot be equal to minus 2. So I write that like that. Okay? That's the domain. Do you need range?
No.
Okay.
Hold.
There's no holes. Holes are created when one of these factors would cancel out with another factor. In other words, let's say I had an x minus 2 in that numerator. That would cancel out with this x minus 2 and take away this vertical asymptote, but it would leave a hole. In other words, just because I'm canceling this x minus 2 out with this x minus 2 does not remove the domain restriction that x cannot be equal to 2. I mean, this would turn into 1 over x plus 2, so it looks like x could be equal to 2, but it couldn't. It'd be a hole at 2. That's what holes are about. Okay? This one doesn't have any holes because nothing cancels.
Okay.
Then the last thing was graph it?
Yeah.
Okay. This is hyperbolic in nature. Okay? Hyperbolic means the following. If I wanted to graph y equals 1 over x, notice that that also has a vertical asymptote going right through the y-axis, has a horizontal asymptote. It's hyperbolic, meaning it looks like this. It never, in other words, both of these curves approach their asymptotes but never hit them. Y is never 0 and x is never 0. So hyperbolic functions tend to look like this. I put a minus sign in front of that, and all of a sudden, instead of the first and third quadrant, it goes into these two quadrants. Okay? So that's what a hyperbolic function looks like. Now, this is going to look something like this. In other words, the function's going to approach this vertical asymptote and this horizontal asymptote. It's probably going to look like this on the other side. And in the middle, it could look like this or like this. And I'll show you how we'll figure out which. First of all, we need to know, is our function in that quadrant up there? So how can I tell? In other words, maybe it's down here as a starter. How would you know whether the first part of this graph is up here or down here?
If it's positive or negative?
Well, let's plug in a value for x to the right of this vertical asymptote and see if it results in a positive or a negative y. So plug in 3 for x. What do you get? Positive or negative?
Positive.
That means this is the right picture. And I'm going to erase that. Okay? So that's part of my graph. Now let's see where it ends up over here. Let's not worry about the middle for the moment, but figure out what happens over here. Is it going to be down here or is it going to be up there? So plug in a minus 3 for x, because this is at minus 2 here. And this is at plus 2. So if I plug in an x that's to the left of that vertical asymptote, it'll tell me whether I need to be up here or down here.
Get a negative.
Okay, you get a negative numerator, you get a negative here, you get a negative there, so you're right, it is negative. So it's down here. Okay? Still there, Jade?
Yep.
Okay. Now that kind of tells me what's going on in the middle. In other words, I know that the middle doesn't do this. It goes through that point. It doesn't go up and touch it and come back down. It goes through the point, because when you're dealing with these vertical asymptotes, they always, in other words, this comes down from positive infinity. Well, on the other side of the asymptote, it comes up from negative infinity. Well, this goes up to positive infinity. On the other side of the asymptote, it comes up from negative infinity. So that tends to be a characteristic of most graphs that are hyperbolic in nature. And the other way we could figure this out is we know that when x is 0, y is 0. But what is y when x is minus 1? Plug that in and see if you get a positive or a negative result.
Negative.
You get positive. You get, this is negative, this is positive, this is negative. So we have a negative divided by a negative, which turns positive, which means I drew this thing correctly. Because when x is at minus 1, y has to be in positive territory. And that's really the only other confirmation I need to show that I got the graph right. Now, just to prove to you that I did, I'll pull it up on Wolfram Alpha, and we'll take a look at their graph of it. It's x divided by the quantity x squared minus 4, right? Wolfram Alpha is nice in that it gives you the feedback. It shows you what you put in. That's what I wanted to put in. There's the graph zoomed in and zoomed out. Notice where my vertical asymptotes are. There's one right there at minus 2. There's another one right there at plus 2. And the thing does exactly what I thought it did. Looks almost exactly like that. Okay?
Okay.
Now, is it possible that when she said graph it, she wanted you to do it in your calculator? Or
No.
she wanted you to do it manually? Okay, good. That's what we did, was do it. We did it manually. And that's the way to graph it, is you start with your vertical asymptotes, you put all your horizontal asymptotes in there, and then you treat it as a hyperbolic function and try to figure out which quadrant that part of the graph is in. Is it in the upper right or is it in the lower right? In this case, it was in the upper right. That told us where this one started. We knew it went through that point, and we knew that this had to be lower left.
Okay.
You got another one?
Yeah.
We'll have to do this one fast, but
It says write the conjugate of the given complex number Z, then find the product of the complex conjugate.
okay. What's the number?
It says Z equals 8 minus 3I.
What's the conjugate of 8 minus 3i?
I don't know what a conjugate is.
Conjugate is where you just change the sign in the middle.
So it's 8 plus 3I.
Uh-huh. And when you multiply an imaginary number by its conjugate, you're going to eliminate the imaginary part of it. Remember that this is the difference of squares factored. So when I multiply this times that, I only have to worry about the first term and the last term, because the two middle terms are going to cancel one another out, and that's always the way it is. So the first term is what?
64.
What's the last term?
Plus 3I squared.
Minus 9i squared, okay. So what's that simplified to?
9.
What's that simplified to? That's equal to a real number.
So
I squared is what?
75?
No, I squared is minus 1. Yeah, 73.
73.
In other words, it's 64 plus 9. Okay, what else?
Okay. That was it.
I'll give you one. Multiply that by its conjugate. First of all, what's the conjugate?
4 minus 3i.
Okay, multiply it. Multiply just the first and last.
So 16, and then minus 9i squared equals 16 plus 9, so 25.
As easy as that. Now, it's only when you multiply that by the conjugate do those two middle terms that contain I cancel one another out. In other words, notice that I have 16 minus 12i plus 12i minus 9i squared. That's the full way to do it. But these two terms always cancel one another out when you're multiplying by the conjugate. That's quite helpful because then you just have to square that one and square that one. Or not square them, but multiply them together. Okay?
Okay.
Got anything else? I got 2 minutes.
I don't think I have anything else.
Okay. I'll only bill for 45 minutes tonight because I don't know how much time we missed, but we certainly didn't get a full hour in.
Okay, yeah.
Okay?
Sorry.
All right, Jade. Let's see. I'm a little unclear here. This is your regular time, right?
Yeah,
At 7:15 on Tuesdays. You want to keep?
Yeah.
You want to keep that?
Yeah.
Okay, I got you down there until you tell me to take it off.
Okay.
Okay, I'll talk to you next Tuesday at 7:15.
All right, sounds good.
All right, bye-bye.